Hello and welcome once again. In this video, we will study about the common gate amplifier. This is the circuit of common gate amplifier. Here input is applied at the source terminal and output is taken from the drain terminal, and this gate is connected to a DC voltage to bias the circuit. Now the input output characteristic. Let us assume that this V input is decreasing from a large positive voltage. We will go in this direction. Then for V input greater than equals to VB minus VTH. This M1 will be off, and in this case V out is equals to VDD. Here you can see M1 is off and this V out is VDD. Now lowering this V input going towards this direction, we have the drain current. So now this drain current is given by half mu n CoX W by L, and the equation is VGS minus VTH whole square for the saturation. So here VGS, the gate voltage is VB, and VS, the source voltage is Vin. So we will write it VB minus Vin and then VTH whole square. So this is our equation 1. Now here you can see M1 is in saturation mode. So this V output is actually given by, in the saturation mode, it is VDD minus ID product RD. So here I have placed the value of ID, the drain current, and so this is our equation 2. Now further decreasing this V input, moving towards this, lowering the V input, M1 enters into this triode region. This is the triode region. Let's find out the voltage gain. So in the saturation mode, the V out is given by, just we have written it, VDD minus ID RD, okay, by this equation. Now differentiating both sides with respect to V in to find the voltage gain. So this voltage gain AV is del V out upon del V in, and it is equals to VDD, it is constant. So differentiating with respect to this V in, it will become 0. So here you can see half, and this is power 2. So we have minus mu n CoX W by L VB minus V in minus VTH. Yes, power 2 is this cancelled out. So next in product, this minus 1 and minus del VTH upon del V in product RD. So after differentiating with V in, we get this equation, and this is our equation 3. Now since this del VTH upon del V in is also del VTH upon del VSB, source to bulk, so we can write it as eta. So simply this equation is, okay, one more thing, negative, you can take out common the minus sign, so it will overall the positive equation, and this much is GM, and we have taken out the minus, so it is 1 plus eta product RD. So this is our voltage gain of common gate amplifier, where GM is given by mu n CoX W by L VB minus V in minus the threshold voltage. So this is the transconductance. Here you should note that the gain is positive, okay, and this body effect is increasing the equivalent transconductance of the stage. This is the transconductance of the MOS M1, and this is our equivalent transconductance GM 1 plus eta. Now this small signal analysis of the common gate amplifier, here we have considered this channel length modulation resistance the current flowing through this resistance is I naught. Now applying KVL from gate to source first and then drain to source. Okay, so first is KVL from gate to source. So writing the equations, V1 and the current flowing through this RS. So we will write minus the current flowing through this RS is V out upon RD and product RS, okay, and then V in. So this is our first equation. From drain to source, it is from drain to source, yes, we have V out equals to this current flowing through this R naught, so I naught R naught, okay, plus the negative current, this one, minus V out upon RD, product RS and this voltage plus V in. So this is our equation 2. Now this I naught is actually given by, let's write the equation for this I naught, and we have GM V1, okay, plus this current GMB VBS, yes, and plus this current I naught, this is equals to the minus V out upon RD. Why I am writing this? Because from this equation we will get the expression for this I naught. So it is taking negative sign common. We have V out upon RD plus GM V1 plus GMB VBS. Okay, so this is our equation 3. Now using equation 1, 2 and 3, solving for the voltage gain, we get this voltage gain AV. It's not actually difficult. I am leaving this task to find out this expression and verify from it. You have to do one thing, use equation 1 to find the value of V1, put in the 3, and then overall I naught expression is substituted in equation 2, you will get this expression. So here once again you can see that the body effect, this body effect is increasing the equivalent transconductance of the amplifier. Now the properties of the common gate stage. So it has a high voltage gain almost equals to this source degenerated common source amplifier, and it has low input impedance, therefore can be used in impedance matching. Its output impedance is very large and it is given by this expression. So this is all about the common gate amplifier. In the next video there will be comparison of all the 3 MOS amplifiers, common source, common drain and common gate. So don't miss it. And if you like this video, then please share and subscribe the channel. If you have any queries or want to suggest something on the topic, then mention it in the comment section. Thank you so much and have a nice day.